Alright, so today I'm going to show you how to find the domain of a composition. So here's an example for you. You got two functions, f of x, you got g of x. Let's say I want to find the domain of f of g of x, right? Well, you might be thinking, okay, we'll just find f of g of x, find its domain, and you're done. But when there's functions inside of other functions, it's a little bit more complicated than that. So let's just figure out the domain of f of g of x. The first thing you actually want to do is you want to find the domain of the inside function first. So I'll even put a list out to the side. Step 1, find domain of inner function. Which in this example, the inner function is g of x. So we found the domain of g of x real quick. G of x is just square root of x. So as we talked about this week, that means the domain would just be x greater than or equal to 0. Great, step 1 is done. Step 2, we need to actually construct our composition. We need to put it together to figure out what is our composition here, or our composite. So let's do that. Let's find f of g of x. Should be pretty straightforward. So plug g of x into f of x. You're going to have a 2 times the square root of x plus 1. All right. Now you need to find the domain of this new function. This composition that we just created, let's find the domain of that function now. Alright, well, again, it's another square root function, so all you do is take the inside of the square root, you set it greater than or equal to 0. So we actually ended up with the same thing. Exact same domain for that piece. So then to get the final answer, you find the intersection of these two domains. And then you'll be done. Intersection meaning, where do they overlap each other? If you graph them both on the same number line, where would they both be at the same time? That's your answer. Now, a problem like this is very easy to find the intersection because they're already the exact same thing. So the intersection would just be x greater than or equal to 0, which in interval notation gives you a final answer of 0 to infinity. And that's your first example. Not bad, not bad. Now, let me see if I can find another one that works out a little bit differently this time. So if we look at this one here, I'm going to give us some new functions. Oh, and you know what? Actually, let's go back to the other one, and let's do the other domain. Let's do the domain of g of f of x before we go to the next problem. So what I'm actually going to do is start it again, but this time look at the other way around, g of f of x. So now this time, your first step, find the domain of the inner function. Well, the inner function this time is f of x. Well, look at f of x. It's just a nice little linear equation. We talked about this. There's no square roots. There's no denominators. So the domain here is just all reals. Negative infinity to infinity. So that's your step 1. Step 2, let's create this composition. G of f of x. What would that look like? Now I plug g into f. Or excuse me, wrong way. Plug f into g. It would be the square root of 2x plus 1 when you substitute. Okay, well now, step 3, find the domain of this new composition here. So it's a square root function. Take the inside, set it greater than or equal to 0, solve for x, and after you've solved it, you'll get x greater than or equal to a negative 1/2. So you've got these two little domains here. Final step, get the intersection of those two domains. I'm going to give you a visual of what's going on here, and I'm going to do this in two different colors. So here's a nice little number line, right? Well, your first domain is all real numbers. So I'm going to shade the whole number line here. So domain 1 will just be regular old pencil. Now I'm going to come back through. I'm going to do a different color. I'll do my second domain in red. So the next domain is all the numbers greater than or equal to -1. So wherever you want to put -1, or -1/2 that is. There's my closed dot. There's my second domain. So the intersection would be, hey, where are they both at the same time? Where are they overlapping each other? Really, it's just the red part already, right? That is the intersection. So the intersection of these two happens to be -1/2 to infinity. That's kind of how it's just going to happen, right? When one of them is all reals, the intersection will probably just be the other one. That's just kind of how it works here. So -1/2 to infinity. That's your final answer. That's the true domain of this composition. All right, I do have one other example here. This one's going to be a little more complicated. But let's check it out. All right, new functions, new f, new g. Let's find the domain of f of g, and then maybe we'll find the domain of g of f as well. All right, well, first step, find the domain of the inner function. It's f of g of x, so the inner function is g of x. So let's find the domain of g of x. Little rational function, set the bottom not equal to 0, and you realize the domain of the inner function, g of x, it's got a domain of x does not equal 0, meaning, all reals except 0. Now let's actually create our composition here. Let's plug g of x into f of x. Notice we got two x's to plug in here, so it's going to be very pretty when we plug this in. So it's 3 times a 2 over x, and that's divided by a 2 over x minus 1. And I would say we should definitely clean this up. And check it out, you got yourself a complex fraction. We've already seen a lot of these this year. Let's simplify this. I'm going to multiply everything by an x, least common denominator. So all I'm left with is a 6 over 2 minus x. So there's your composition. There's your new function. So now we got to find the domain of that. Okay, shouldn't be too bad. Nice rational function again. Set the bottom not equal to 0. And you'll quickly realize once you solve it out, x does not equal 2. So there's our second domain for this problem. Now we find the intersection of those two, the inner function, the new function. Find their intersection, and then you'll be done. That'll be the final answer. Again, if you're a visual person, you can use your number line to do this. So the inner function's domain is all reals except 0. So if I were to shade this on the number line, I'm going to shade everything except leave a little open circle at 0. Okay. Well, now let's put our next domain. It's all reals except 2. So in red, the domain will look like this. All real numbers except 2. And what you need to do now is go through this whole picture and think, where did both colors happen? Okay, well, right out the gate, you've got both colors. So negative infinity, all the way until 0 does not count. Because remember, that was an open circle for the pencil shading. So as I'm writing my intersection, I got negative infinity, and then I stop at 0. Union 0 until 2. Again, 2 didn't count for the red section, so I can include that in my intersection. But then after 2, it's all both colors again, so 2 to infinity. So pretty much all reals except 0 and 2 would be your final answer. That's the domain of this composition function. So again, different colors definitely helps. Let's do it the other way. Now let's do one more. We'll do the domain of g of f this time. G of f of x. Alrighty, same functions, just different order of stuff. Now the inside function is f of x, which I'll rewrite it down here. There's your f of x. Let's find the domain of this inner function. Another rational, set the bottom not equal to 0, and you'll realize the domain of the inner function, x cannot equal 1. Cool. Let's create this composition here. So when I plug f into g, what are we looking at here? So f will now go into g. So it's 2 over this whole expression here. So you got a fraction underneath a fraction. Like so. Easiest way to simplify this one. Remember, anytime you're dividing by a fraction, that means you're technically multiplying by the reciprocal of that fraction. So that'll help you clean this up very nicely. And since you're going to multiply a 2 over here, make sure the 2 distributes, so it becomes a 2x minus 2 on top. So there's your new composition, g of f of x. We need the domain of this. Okay, another rational function, so I set the bottom not equal to 0, and I'll quickly realize its domain x does not equal 0. So I now have my two little domains. Got the inner function, got the new function. Let's find the intersection of those, find where they overlap, and that is your final answer. You don't have to do the sketch, completely up to you. So, let's see, this domain was all reals except 0, so I'm going to throw down an open circle at 0 and shade everything else. And then I have my second domain was all reals except a 1, which would be something like this. Shade everything except 1. Try to shade it a little differently. It will stand out better, hopefully. Alright, so the overlap, the intersection, it's all reals except 0 and 1. Everything has an overlap except at 0 and at 1. So that's your final answer. So it's negative infinity to 0, union 0 to 1, union 1 to infinity. And that's the domain of g of f of x. That's the final answer. So yeah, the steps again. Find the domain of the inner function. Find the domain of the new composition function. And then find the intersection of those two answers and you'll be done. And again, I would suggest the shading on some of these, especially when they have some crazy overlaps going on, like if this one's got this piece, and then let's say another domain has this piece, and you have to realize, oh, okay, well this part here is where they overlap, that's your intersection. So, you know, drawing can help. It's up to you. You can do it, you don't have to do it, whatever helps. And I believe that's it. So, of course, just hit me up on Remind if you have a question. Otherwise, have a great day.